Hello everyone, I am Shubham Garg and today we are going to see the tutorial of the software DSCH. DSCH is a software from Microwind and it deals with the schematic, the layout and everything in the VLSI field. Alright, so here in this DSCH we will be seeing to make the schematic of different circuits, all the basics of the DSCH software. Although most of the industries prefer Tanner tools or mentor graphic tools or other tools, but I think DSCH software is very beneficial for a beginner level so that a person is able to get a feel of what is actually happening inside a VLSI circuit. Alright, a person can easily understand the working of MOSFETs or any logic gates or anything and by visual parameters, by seeing the visualization of the circuit. So that's why I feel DSCH is very helpful for understanding purposes. Alright, and it is a fact that most of the companies uses higher tools like mentor graphic tools, Tanner tools in the actual industrial work. So we will start from here to see how everything looks like in this DSCH software. Alright, so this is the window of the DSCH software. Here you can see the options like file, edit, insert, view, etc. And there are a lot of buttons here. Okay, so we will see what these options are in detail. So first of all, this is a new screen which will be visible to you when you first start DSCH. Alright, and here let me just show you all the options which are available. Okay, so this one is open file, this is save file. This is for making the symbol, that is when we make a schematic, then we can convert it to symbol. This is for selecting a component, we will add some component. This is for cut, next for copy, move and rotating the component. So these are the symbols like that. This is for adding text to our schematic. This is for wire and a connector for the wire. And this is to run the simulation and viewing the timing diagram and all these things. It is zoom in, zoom out, our layout which we are working. You see if I am zooming in here, you can see the layout is getting bigger or smaller. Basically the cell size is not affecting, just the view is zooming in. Alright, so these are the options which are available here, and you know this is the this is the screen where we will be making our layout, and you can see there are some dots in blue colors. Okay, here we will be making the schematic on this screen. Alright, basically what happens when now we will be making the schematic only, but when you go for the layout, you need a layout editor. Either you use a layout editor for Tanner or mentor graphic tools or L-edit, or you can use the Microwind layout editor as well. So there will be this kind of grid as well, and the size between the two dots will be measured in terms of lambda or microns. Okay, and so that we have a specific standard size of the layout according to the technology files. So that is the stuff for another lecture, but in future we will discuss that also. So now we will see the basics of this DSCH software. Alright, so now you can see here the options where file, new, you can see opening your schematic, saving a schematic and everything. Edit options are here as well, insertion, view, simulation and all that. Okay, so let us start by adding some symbol or adding something to our schematic. So I will go to insert and use a symbol. Okay, before that I should show you how the files will look like when you install the software. So after the installation of software, this is how your DSCH folder will look like. You will have options here like examples, HTML, IEEE, system, and the configuration settings and all these files. Alright, so basically in the examples you will have a lot of schematics and symbols already built by default from Microwind DSCH. Okay, and you can use them in your circuit as well. Like for example, you can see here 2 NMOS which is in series, the adder, add 4, most probably it is for adder for 4 inputs. Okay, you can see full adder, inverter, these kind of all the components which are here, NAND gate with 2 inputs from CMOS and all that. All right. So this in the system folder you will see the application, that is DSCH3. Okay, and from here you need to run your applications. Okay, you just need to double click it and it will open as here. So once when you open, okay, I will close this one. Yeah. So once it's open, you can start inserting the symbols and make your schematic. All right, so we will see from the insert option, you can go to the user symbol. All right, and here in the examples, you can see you can insert anything you want. All right, or if you have any symbols in any other folder, you can insert from there as well. You can see in the IEEE file, there are these kind of symbols, that is, let me just see, okay, it is not maximizing. Yeah, there are these kind of symbols, that NAND gate, 3 input NAND gate, 2 input NAND gate, mugs, latches, and a lot of symbols. Okay, for example, let's say I want to insert a P-type MOSFET. So I will just search for PMOS and I will click open. Okay, and you see the dotted line here, this is our P MOSFET, and we need to just move the mouse. We can paste it anywhere. So here. Now you can see this is the PMOS. All right. So when you double click it, you can change the properties of a PMOS. Okay, this is the width, channel length, this is the model, this is the name and title and the position. These are the coordinates of the position. All right. So there are the 3 terminals, source, gate, drain, as there in the MOSFET. Okay, we can select the option to show pin names or symbol title, it's up to us. So these are the various options which is available. I will just show pin names and I will click OK. So as we can see, this is the gate, this is drain, and this is source terminal. So this is how we insert a symbol. Now you most probably be wondering that there is a symbol library which is present there on the right side, and there are symbols as well. So you might be wondering, why can't we just drag the symbols from here? Okay, so in the beginning, when you will be dragging the symbols, you will be seeing this error message that the symbol this is not in the directory. Okay, so first we need to set up the directory of the symbols. So for that, what you need to do is you need to go to File, and here you will be having the options, that is Properties. Okay, now here what you need to do, you need to just remove this system. Okay, in the home directory there is DSCH system, so you need to remove this system and press OK. So once you do that, you will see you will be able to drag any symbol from here. Okay, so for example, I drag this button, I can drag this voltage VDD, I can drag ground, anything. So here is the basic and here is the advanced symbol like resistor, capacitor. So I am able to drag any symbol, anything I want. All right. So for now, I will just delete this symbol. Okay. So now, as I told you, this gun type of symbol is used to delete it. So just select the gun and select the symbols you want to delete. Just click on them and these symbols will get deleted. So this is how the basic layout, basic schematic looks like the software in the software DSCH. All right. So this is our PMOS. We can move around using this select option. Okay, that is this red arrow. We can move it anywhere in the schematic we want. Now here are the rotate option. Okay, first let me show you the copy option. Okay, just click on the copy option and click on the thing you want to copy. Click on the component and it's just done. It is copied and you can paste it anywhere. All right, you can copy it again. Okay, and it is here. Now let's say you have made a bigger schematic. You need to copy a lot of components, not only one. So what you do is select copy and press left click and drag it like this. Okay, now all three MOSFETs will get copied. So you can, for example, if you need to use any kind of circuit, you need to copy paste, you can copy and paste the whole circuit. Okay, so this is how the copy and paste option works. Now next thing is rotate. For example, this is your PMOS, you need to rotate it left or right. Just click on here, this is for rotate for left or rotate to right. So you can see it is rotating to left. Just click on rotate to left, then click on the symbol. Similarly, rotate on right, click on rotate to right and click on this symbol. Alright, now this thing is flip, horizontal and vertical. So you see, just click on flip and it is going to flip horizontal, click on flip vertical, it will be flipping vertical. Alright, so these are the basic options. Now this is for text. Let's say I write text here, just click on the screen wherever you want to place the text and write the text you want to place. Okay, for example, I want to place here, I will just click here and I will place my text here. So there is our text. Similarly, if you want to delete the text, just click on the gun and click on the text to be deleted. Alright, so now this is the text and this is for wire. So you can see I will just click here, add a line and I can make connection from anywhere I want. You will see here I can make connections. Okay, this is just random connections, not actually making any circuit. So this is how you can connect using the wire. Okay, any way you want. Like you can connect anywhere. So you can see when I connected this wire in the middle. Okay, first of all, see here the zoom option, that is we can just zoom in and zoom out. That is to show there is a connection in between them. All right, in the MOSFETs there are already the terminals, so it gets connected, but in this wire here, these green color dots show that there is a connection here. Sometimes due to some reason, let's say there is no connection between your wire. For example, let me just delete this wire first. Okay, now what I'm going to do, I'm going to create a wire from gate to the gate terminal of this MOSFET to here. All right, so I have created this wire. Okay, it is making this interconnection. Yeah, so now let's do this. Yeah, for example, see here, now there is no interconnection between these two lines. Okay, the vertical and horizontal wire, these are not touching each other. Okay, so you need to make sure in the circuit sometimes that you need to touch the wire or not. So if there is a green dot here, then that means there is a connection between these two lines as well. But since there is no green dot, these two lines are not connected. So if you want to connect these two lines, you need to add a connector. Okay, just click on add a connector and click here and boom, your connector is here. There is the green dot, that means now these vertical and horizontal wires are also interconnected. Okay, so you need to make sure according to the circuit which you are going to design, that whether you want to make an interconnection or not. So this is the basic stuff, basic options which are available in the DSCH. Okay, that's how you enter a schematic, you make something. All right, and this is pretty much it about the basic things. So I will just delete everything which is every component and wire which is present here, and we can move to the circuit, any basic circuit which we want to design or which we want to make. Okay, so now also one thing I should remind you again, that the industries basically prefer higher level softwares, that is mentor graphic tools or Tanner tools or cadence tools, etc. Okay, but this software is also used in some industries, but this is what, from my point of view, it is better for understanding purposes. Whether you are a VLSI student or an electronics student, you can see the flow of how things are working. Okay, and you don't have to put much effort in making the schematic. because on the higher softwares you have to put a lot of effort to first of all learn and understand the software. So here you can build a schematic and everything easily, and you can easily understand the flow of how things are working, how is your MOSFET is running, how is your AND gate or NAND gate is working. You can see everything. All right. So now let us make a very basic design, that is the inverter. All right. So we know the schematic of inverter. Those who know it is great. Otherwise, I will tell you, don't worry. For an inverter, what you need to do for inverter using MOSFET, you connect a PMOS and an NMOS in series, and then you need to connect the input and output and voltage and ground. That's all. Okay. In upcoming videos, I will explain that in detail, that why is inverter made that way and why everything is happening. But in this video, I just want to show you the flow of how the things are working here, and that's why I chose this inverter circuit. So don't worry if you don't know about the inverter circuit. I will tell you in detail in upcoming videos. So here I will select one P channel MOSFET and I will drag here. Similarly, there is this N channel MOSFET and I will drag it here. All right. So now what you need to do, you need to connect this using a wire and connect these terminal like this. For the output, both the drains are connected, and for the input, the gates are connected as well. Okay. So now first of all, let me just check this option to show pin name, so you will be able to understand. Okay. So you see both the drains, because drain is for output, both the drains are connected here, and from the source we will be supplying VDD and ground, and in the gate terminal we will be supplying the input. All right. So this is how the inverter looks like, and don't worry if you don't know about the inverter. We will study PMOS, NMOS, CMOS, everything in detail. So this is a CMOS inverter. Okay, and here you can see this button option in the symbol library. So this button option is for the input. So just drag and drop this button option, and here you will be supplying this input. So what you need to do, just connect the button to here towards the input. So just select the wire, and from the button terminal just extend the wire, and your input is connected. Okay. Now here is the supply option, that is VDD. Okay, this is the voltage, just drag and connect here, and this is the ground. All right, just drag and connect here. Again, for the output, now what we will do, we will select an LED for the output. All right. So as I was saying, for the output we will be connecting the LED. So for here you will be dragging the LED, and just need to drag here. So once you drag the LED here, you need to connect using wire. Just select the wire from here, and from the output port of LED, you just need to extend the wire to the output. All right. And now your inverter is complete. You can see the other terminal of LED is already grounded. So now this is our inverter. There is a PMOS and an NMOS in series. The input is applied to the gate, which is both the gates are connected to a wire, and the input is applied, and both the drains are connected, and the output is supplied to drain. Okay, and on the source we applied VDD and ground. All right. So you can change the properties of any component as you want. So you can see here the VDD value is 1.20 volt. You can change it to anything you want. This is the ground parameters. You can change it anyway. This is the voltage. Okay, you can also change the color. This is the LED, sorry. Yeah, this is the LED. You can change the color of the LED if you want. You can change the name or anything. Okay. Let's just move it back here. Yeah. So this is the input parameters. Again, for the button, these are the options. You can explore more options as you work on this software. All right, so now what we should expect, that we all know the functioning of an inverter. Inverter is basically inverting the output, inverting the input. Okay, so for example, if we supply 1 to the input, it will give 0 to the output. If we supply 0 to the input, it will give 1 to the output. So that means that if the button is off, that is the switch is off, it is at 0, the LED will glow. All right, and if the switch is on, that is the voltage is supplied, the input is supplied, then the LED will not glow. That is the functioning of inverter. So let's see if our circuit is working properly. So you need to do is click on this green button, that is run simulation, and you see now the button is off, switch is off, so LED is glowing. And when you switch on the button, LED becomes off. So this is how the button is, this is how our inverter is working. And you can also see that when the button is off, this NMOS parameter, this NMOS transistor is open and PMOS is shorted, and when the button is off, the PMOS is open and the NMOS is shorted. Okay, so basically that's how an inverter works, and we can visualize what is actually happen inside the inverter. All right, and this is just the basic, the purpose of this video is to show how a schematic is made and how we can simulate it, for why the inverter is working this way, and all the details of inverter and MOS PMOS we will be covering in the future lectures. So don't worry, those who have recently entered in the VLSI field or don't possess the information about inverter, we will cover everything in detail. Okay, for this lecture, this is enough that you should know this is how a schematic is working. And from the next lecture, we will be seeing the PMOS, the NMOS, everything separately and why it is working that way. And from that, we will gradually go up to the bigger circuits. So this is a basic demonstration of a CMOS inverter and how it is actually working in the DSCH software. I hope you all learned something new. So I will just stop the simulation here. So this is the stop simulation button. And before that, there is a timing diagram option I want to show. So when you click on the timing diagram, you will see the waveform. Okay, here you can see that after this much seconds, I did the input 1, so the output became 0, and then I make the input 0, so the output became 1. So basically, the much time I am taking to switch the input and output, this is all getting plotted in the timing diagram. Alright, so here you can visualize your waveform and you can judge whether your circuit is working correctly or not. Alright, that is, you are getting desired output or not. So here, once again I am telling you, this is the button for start simulation and stop simulation, this red button. So just click here to stop simulation. Now one more thing is saving your schematic. So to save your schematic, you need to go to File and select Save As. And here, you need to select the folder where you want to save. So by default, it is saving in IEEE. So I will just write the name, that is inverter, because it is a schematic of an inverter, and I will just save it here. All right. So now let's say I close it, and when I open it, I can open my schematic from File, Open. And here you can see by default it is seeing in the IEEE folder, and it is showing inverter.sch, that is our schematic. So when I open, this is our schematic which we just built. Alright, so this is all for this video, and we will discuss everything in details about the MOSFETs, PMOS, NMOS, its working, and more about VLSI in the future lectures. And after covering the DSCH, hopefully we will move to some higher level tools like Tanner tools or Mentor graphic tools. But for basic learning and to understand the flow of how things are working, I prefer DSCH, so that we can correlate from the theory that what is actually happening inside of a circuit. All right. So this is all for this lecture. See you guys in another video. Thank you.